As I was saying, we are really happy to be here. My name is Jesus.
My name is Manuel and Hernandez.
Yeah, we're both integrations engineers at SysDig, and we are also the maintainers of PromCon.io, which is an open source project. It's an open source project that gives you a curated list of Prometheus exporters that are ready to go. You go there, so it's search for the application you want to monitor, and the configuration and the alerts and everything is there. We are transitioning now to a full open source mode, so it's not complete yet. You might find some weird stuff, but we are working on it like full. In this talk, we want to show you guys how easy or not so difficult to secure a Prometheus server and its exporters with some things we learned from OpenShift. This year, it's been a very exciting year. We've worked with a lot of OpenShift clusters, and at first we struggled of how to get information from the Prometheus exporters, how to interact with it, and it was quite an adventure at first. So we are going to talk about it. First, I mean, Prometheus only contains metrics, so it's not account numbers or emails or passwords, right? So should we monitor it?
Well, yes, we should.
We should, yeah.
Because there is a lot of public information out there. If you filter with Fabricon in Sudan or in FOFA, you can find a lot of open endpoints on the internet, node exporters, APIs, consoles. So just with a query, you have there a link where you can see there's a lot of hashes, and you can see a lot of applications out there. Prometheus is in there. So
basically, you can access to a Prometheus consoles, and of course, their metrics. So what information can you get from that? At least you guys know you have used the node exporter and the KSM, and those two exporters have a lot of information. So they are given the attackers like the perfect surface of attack. It's like they don't need to. It's a no-brainer for them. They just go there and see namespaces, secret names, types of secret. So, for example, this is a few metrics we found. You can just with the time series, you can get secret types. You can get load balancers open to the world. You can find image versions, kernel versions, OS versions, and even the I/O zone where you are working in AWS. So, I mean, they are gonna be attackers everywhere, but at least we have to give them a hard time. So if you give them the host and IPs, you're giving them the topology of your infrastructure. So they won't need to do any scanning or discovery techniques. They won't need to perform any brute force attack. So their attacks will be low profile, and it might not trigger any alarms. Also, if you give them the versions of your internals, and those versions aren't up to date, they might use some known vulnerabilities to attack. And of course, registries and image versions, if they are public, they can try to confuse you with really similar images, but not so good intended. I hope you are at least afraid right now, like, wow, this is serious. If you want to dig deeper into how attackers use Prometheus servers to exploit your clusters, you can take a look at this talk. From the last KubeCon in Valencia in May, it was a talk from two colleagues, David and Miguel, that they covered this more in depth. So, now that we know the problem, what can we do about it?
So this is the typical Prometheus installation. So the data normally is traveling in plain text. The exporters, most of the exporters are not secure, not using TLS, SSL. There's no authorization authentication between Prometheus and the exporters normally. And the consoles or API are accessible to anyone internal. And we have seen a lot of consoles are also external. So we saw that there's a lot of important information out there. So let's explain how we do this with OpenShift, or how OpenShift secures the Prometheus environment. So Prometheus, basically, we're going to talk about all this information, role-based access control plus Kubernetes proxy. This is the first thing that Prometheus or OpenShift applies to the environment. Then you have the OAuth 2 authentication and different Prometheus servers for different use cases between, depending if it's an administration use case or a final user use case. So let's talk just a little bit about Airbag really fast. It was released in Kubernetes 1.6. Basically, it's who can access to what resources in the cluster. So we have user accounts and service accounts. We have the roles and the cluster role, depending if it's only for a namespace or the whole cluster. And then to bind that service account and that role, we use a binding or a cluster role binding. This is an example on how to apply the Airbag for Prometheus.
Yes. We are going to go through this fast because right now, if you use the standard, the official Helm chart for Prometheus, this is already configured.
Out of the box.
We just want to show you how it's done. But basically, you need the what, which is the role, the who, which is the service account, and then you need to associate them with a binding. And this is how Prometheus does it.
Yeah, so really fast. We create here a cluster role with the following resources that it's going to access Prometheus. Prometheus only get, list, and watch. It's not going to delete nothing nor date. And then the non-resource URLs, because Prometheus need to access to the metrics path. So that's a non-resource where it can get. Then we create the service account for Prometheus. And we bind it with a cluster role binding as Prometheus need access to the whole cluster.
So here's where they say, OK, so Prometheus can access this role, these things. And you say to your workload, so this Prometheus workload is this service account. So from that moment, Prometheus will be able to access. If you configure the jobs correctly, right?
Yeah. Once we have the service account, we have to tell our jobs to use something to have this authorization. So we have to put a token. The token automatically, Prometheus gets it when you run and you assign a service account. So the only thing we have to do is give this credential that Prometheus will use when attack the exporter or the Kubernetes internals. So
this is easy because Kubernetes already manages the security of their internals. Kubernetes is already configured to and gives you this role that you can use and these resources, so it's easy. But what happens with exporters? Because we also want to secure our exporters. Well, Prometheus exporters are like any application you can run in your Kubernetes cluster. So you need to configure the authentication and authorization manually. And this is really important because the kubelet, by default, is in mode always allow. So this is a really important question. The thing is, what you have to do is use Airbag for authorization, use a service account for authentication. So basically, from a token, you need to know who is it, and if it has the permissions to request that resource. So Kubernetes, again, Kubernetes exporters can rely on Kubernetes internals, but what can we do with exporters? Well, this is a problem that it was solved by this guy, Frederick Brandzik. He created the Kubernetes proxy, which he presented in a lightning talk. And it's such a cool project, such useful that OpenShift forked it, and it's using it in the platform. So OpenShift is securing the exporters using this. And here you have it's like his line in talk. Just 5 minutes, I think he could have done a 30-minute session with no problem. So how does Cube RBAC proxy works?
Yeah, basically, Prometheus tries to scrape metrics. So then there's the Cube RBAC proxy, which says, hey, stop, who are you? Why are you trying? What are you trying to do? So you get the service account and the token, and the RBAC proxy forwards the petition to the API. And then if it's everything OK, it proxies the RENA request to the node exporter, console, or whichever you are securing.
So let's see an example. We are going to show you how you can secure the Nginx exporter. The full example is in this gist in GitHub. We'll publish the presentation later. But we are going to see just the key parts of the configuration because it's a lot of boilerplate. Basically, what we are going to have is along with the Nginx server, as sidecars, we're going to have the exporter itself, and then the proxy that will secure the exporter, right? So what can we do with this?
Yeah, so basically, here is the definition of the RBAC proxy. So the port which is going to listen, that default is 8443. And then you have the upstream, which is the port where the metrics is being published by the Nginx. So it's the default as well, 9113.
Yeah, we use the 8443 port because it's the default port that OpenShift uses. So just but you can use the port you want.
Yeah. Then we have the Nginx exporter address, which is localhost. It's really important because if you publish in all the interfaces your port, anyone in another port could access. So we only want our RBAC proxy to access to this information. Exactly. So that's an important thing.
So with this configuration right now, Prometheus won't be able to scrape this because we only gave access to our proxy. So Prometheus will access this proxy to get the metrics instead of directly from the exporter. Okay. The other thing this software gives you is a lot of logs. So you can control different situations. You can see when your data was authenticated, what your request was, your user was authenticated or authorized. You can see easily what's happening. So it's really handy when you are doing things. And this is right how you can configure the job exactly the same as we were configuring the Kubernetes nodes exporter previously. You need to simply give the token. We'll see in a demo in a moment. Also, you need to replace the port where Prometheus will do the request because the port of the exporter is closed. So, do you want to see this in action? I guess so. And if you don't want to, I'm sorry, you're gonna see it. Okay. Just a second. Okay, so we have a Prometheus server here and our application, which has the three pods, the three containers, the exporter, the Nginx server, and the proxy. And from the exporter, you can have the metrics. From localhost, this is OK. But let's try from another pod. So we can deploy a pod. We get first the IP address. On the port. We run a curl test pod, and we try to do the same. And we can't. The port is closed. But what's with the proxy? The proxy says you unauthorized because you have no permission. So let's give our pod permission to do this. So basically, we are going to create now a role and associate it to the service account that the namespace have by default because we didn't want to create a service account just for this. But deleting pods in Kubernetes sometimes is slow. we're sorry about this. Okay, so this is the cluster role. And this is the binding, where we bind the service account to that role we created. And it's in the default, it's a cluster role, so every pod in that namespace would be able to access this proxy. So we apply this, and we try again.
Retrieve the metrics easily.
Yes. Even if you are exposing your Prometheus console internally to your organization, you might not want any person in your organization to have access. So maybe you want to have some permission management software to do this. You can do this easily with OAuth. Everyone knows OAuth. Basically, is like the standard authorization. It's an open source authorization protocol, and it's like an open standard. Basically, in order to access to a resource, you have to have a token. In order to get that token, you need to log in against the OAuth server. There are a lot of ways to do this in Kubernetes. There are already ways to do this. There are software that you can deploy directly that does it for you. But we did it this way to see all the architecture that you need.
Yeah, we are using Gmail Auth as the provider that is going to authenticate us. So basically, we deploy the Auth 2, which is a proxy, as well as we saw with the airbag. So the address is the 4180, and we have the callback, which the petition will come to us.
The 4180 is where the OAuth server is working. Mm-hmm. You have to configure it. It depends on the provider you're using. In Gmail, you need to configure this. And then you need a service, because you're going to have an ingress. And this is how you expose it, your console, with that name, with that DNS, test.myprometheus.com, and you associate it with your Prometheus server service. And then you create another ingress for the OAuth, the URL that your OAuth uses. Mm-hmm. So basically, you all know how this works, but so what I'm talking about is this.
So we are accessing here to a domain we've got, so to the console, and we'll see that we first have to authorize and authenticate with Gmail. So, well, don't use the Gmail because it belongs to me. And then we put the password, we accept our token in our mobile, and then we get to the console. So we can filter what department can access to the console.
With group of users.
With group of users. So we can use Azure services, GitHub, Gmail, so any provider on the internet.
Yeah. This way you use Prometheus just for what it's intended to be used, to metrics and observability. So the other thing that OpenShift does, which came to our attention, is OpenShift differentiates the system scope from the user scope. So this is another way of isolating the users from the administrative tasks. So you can have a Prometheus server, which by default in OpenShift is in the OpenShift monitoring project or namespace for the API server, the operator, the etcd, node exporter, blah, blah, and this is one Prometheus server. But you can't configure jobs, custom jobs in that server. If you want to do, you should not. You can, yeah, you should not. You can do it. We did it, but you shouldn't. The suggested way of doing it is by creating another Prometheus server in another namespace, just for the users, for your business logic, your exporters, wherever. And this way you are isolating users from administrators. Obviously, you can see there are shared resources between them. You can have a shared alert manager or a Thanos query or things that are in the middle. But the metrics are in separated databases. So let's sum.
Yes, some best practice summary. Always use the Helm charts, the official Helm charts, because it includes the airbag, it's straightforward, and you have different flavors. You can deploy just the server with the alert manager. You can deploy all the operators. And
Today is a no-brainer, right? You want to install Prometheus, it's just a point of just a couple of commands. And you should use TLS at least. OAuth isn't as complicated as some people think. It's just a couple of configuration. And with Cube airbag proxy, you don't need to configure all those authorization authentication manually. So this is a very nice way of securing your exporters. Your exporters, I mean the exporters you are using, because sometimes you don't know who those exporters are. And of course, it isn't a good idea to expose your API, your console to the internet, because bad people with Sodan can find you. So that's all. Basically, Prometheus have sensible information. We need to secure it. And airbag is not that difficult as it sounds. It's just who can do this, who, and how we can relate to them. So that's all. That's what we learned. I hope it was useful.
Thank you, everyone.
Thank you.
Does anyone have any questions? Okay, going once, going twice. All right, let's, does anyone know where the next speaker is? Thank you, anyway.
Thank you. Yeah.